Okay, today in honors pre-calc, we are doing rational functions. So far, we started with learning about holes and asymptotes, so the horizontal and vertical asymptotes, and x-intercepts and y-intercepts, all that kind of stuff. Then we sketched them. And then this day was the day right before Thanksgiving. And basically, all we did was practice sketching the rationals so that you were really good at it. And I mentioned that we were going to be doing rate problems because they're like fraction functions too. Well, today we need to kind of reiterate what we were doing right before we left for the Thanksgiving break here on the 27th. So there's two files listed for today. We're not going to like do every problem in both, but I'm going to use some problems from this and some problems from this. So if you can find the smartboard that is under today's date, which yes, there are two of them, and I'm going to basically try to get across the word problem part of it today. Then the next day will be the 28th. We will be doing the review for the Chapter 7 test tomorrow. Then again, the current plan is we will try to test then on Wednesday of this week. All right, so if you can find this, I'll pause for a minute while we get these open. There's two files for today. Let's start with this top one. All right, on the third page of today's file, we have a classic kind of typical rational function that you're supposed to be able to sketch by. So let's do one together to bring this back into your memory banks. Let's look at number 9. And you may recall one of my favorite sayings in math is if you can factor it, you should. So let's actually factor this puppy. And I hope, without any help from me, you should be able to factor the top and the bottom. Then I'd like you to figure out the vertical asymptotes. They have to do with the denominator. If there is a hole, tell me where it is, and I want specifics like is it at 2, 8, or where exactly is the hole? Next up, I'd like to find the horizontal asymptotes, and you may recall that that's about Bob. Okay, they aren't all Bobs, but that's those rules about bigger on bottom, bigger on top, that kind of stuff. Next, I'd like you to find for me the things that make the function 0. If this is f of x, what makes the function 0 is if the top part becomes 0. Okay, and that's setting y equal to 0 finds you the x-intercepts, also known as the solutions, the things, the zeros, the things that make the function 0. And then I'd like you to find the y-intercepts. The y-intercept is where you stick in x is 0. And last but not least, I'd like you to sketch it. And let's say it looks like this. There's a couple asymptotes. Just make me a sketch kind of like that. And that's not the actual answer, but you know, a sketch kind of like that. All right, I'm going to pause for a second when you give that one a try. Okay, we need to get started on this thing. For the factoring part, row 5, person 3. That would be you, Mr. K. What did you factor the top and the bottom to? That works. Excellent. How about the bottom? Plus 3. All right. So then just double checking that one, and that appears to work. Do you guys agree? Okay, good. Was there a hole created? Yes, because this thing canceled. That created a hole at -3. -3 comma what? When you put the -3 back in the function, you could put it in the original or in this. Actually, you can't. I'm wrong. If you put in a -3 in the original function, it will just turn into 0. Why? Because of this part. You know what I mean? You can't put a 3 into the original, but you can put a -3 into this guy right here. What I call that is the resultant function, the function that results after you cancel the x plus 3's. Right, and that should have come out to -7 over -5, which is 7/5. Is that correct? Is that what you guys got? Okay, cool. All right, that's where the hole would be. Next, the horizontals. Is this a bigger on bottom, bigger on top, or same on both? Degree is the same on both, and therefore it's a y equals the ratio of the lead coefficients. There's a 1 and a 1. Y equals 1. Ergo, a dotted line right there. Okay, next up, the x-intercept. The x-intercept is where y is 0. This needs to be 0. For this to be 0, the top needs to be 0. What makes the top 0? Well, be careful. You might think a -3 would make the top 0, but that actually just crashes the function because you have a -3 on the bottom also. And that makes it 0 over 0. So really, the only thing that makes the top equal 0 is that part. So x equals what? 4. The x-intercept should have been at x equals 4. Why not at -3? Because there's a hole. When you stick in -3, there's a hole there, not an x-intercept. All right, lastly, the y-intercept. The y-intercept is where x is 0. If I plug in a 0, I'd rather do that at the beginning. 0, 0, 0, 0. This all cancels except that. Really quick and easy. And then I get -12 over -6, +2. If it's a y-intercept, then its x is 0, comma, 2. You put all those things on the graph. Once I get all those on the graph, it's going to be a lot easier to see where this thing should be. Oh, and I didn't say the verticals. The vertical asymptotes would normally have been these two things, but one of them's a hole. So the one that was a hole can't be an asymptote. So the one that's left that's an asymptote is at x equals 2. So here we are at x equals 2 with a dotted line. And then if I fill in a few important points, like the y-intercept is at 0, comma 2. Wait, is that right on the, let me make sure. Oh, y equals 1. Okay, good. I'm in the right spot. All right, good. Next up is the x-intercept is at x equals 4, and that's like right about here. And now, if I wanted to take a gamble, I could just go, okay, it's going to generally look like this and this. But wouldn't it be smart to have a couple more points in there just to be sure? Yes, make an XY chart off to the side and just try a couple more points, like maybe something a little bigger than 4, like maybe 5. If I put a 5 in the function and see what I get. Put a 5 in here and here and here and here. It's a little bit of a pain, but it'll give me a more accurate answer. So I'd get on the top, I get 5 minus 4 is 1 times 5 plus 3 is 8. So that's 8 on the top. And 3 times 8 on the bottom is 24. 8 24ths. And that's the same as 1/3. 5 comma 1/3. Does that make sense? Yeah, there's a dot right where I kind of thought there'd be a dot. All right, last thing, the hole. The hole is really easy to forget. At -3 comma 7/5. 7/5 is above 1, so it's above the dotted line, so that makes sense. At -3, right there in the graph, it goes up to -3, but then it doesn't actually touch, and then it keeps going. That's how you represent a hole in your graph. That is a good, typical question that you'd have to be able to do on Wednesday. Any questions about any parts of that? All right, then we need to move on. So just imagine for a moment the same exact problem wasn't about graphing it. What if it was about when is this, I'm going to erase it and go back to the beginning. When is this bigger than or equal to 0? Do you get my graph can kind of answer that? When was it bigger than 0? Would you agree in this whole zone here, it was above 0? Yeah. Do you get in this little zone here, I'll do with technical difficulties. I'll just try using a different color marker. In this zone here, it was actually below 0. And then I'll use blue this time. From here over, it was again above 0. So the only place where it was below 0 was where that dotted line was up until it hit 0, which was at 4. So between 2 and 4, when x was between 2 and 4 is when it was below 0. I said greater than or equal to 0, so I guess I better do it the other way. Okay, when was it greater than 0? From negative infinity up until it hit, like this is this zone I'm talking about right here, up until it hit that asymptote at x equals 2, so up until it hit 2, and actually equal to 0 at 2, so it actually would work. And then the other zone where it goes above 0 is in here, here to here, and that was from the asymptote. No, that was from at 4, the x-intercept. There you go. The x-intercept was where y is 0. So from 4 to infinity. And how about at 4? I want you to talk to your partner about 4. Do you think 4 makes it greater than or equal to 0 and thus should work? Or does 4 not make our function greater than or equal to 0? Do you think it works or not? Bracket on the 4 or not? I'll pause for a second. Okay, so let's answer the first question, which was, how about the 4? Do you think the 4 works and thus should have a bracket? I agree, because when you actually put in a 4 into this function, it will be 0. Remember, that's the thing that made it equal 0. It was the x-intercept. It will make the function equal 0. And is 0 greater than or equal to 0? Yeah, it is, so it works. Okay, and then a kid brought up a good point. What about the hole here? Is our function actually, at that hole, is our function actually positive? No, it doesn't exist at that hole. Okay, and so I think I should adjust this and say it works from negative infinity up until the hole, which was at, where was the hole again? Negative 3. Then starts working again after negative 3, all the way to 2. And then from 4 to infinity. This was a really tough one. They're not going to be that difficult on the test because that's got that hole thrown in there, which makes it much more complicated. Yes? Okay, now the question about the 2. Does 2, at 2, does it make it work or not work? If I put in a 2, it makes the function crash. You are correct. 2 cannot work. It would need a parenthesis. All right, I'm afraid I've made that one too difficult, and you guys caught me in a technicality. I did not want to make it this hard, but you're right. The 2 does not work. There we go. Okay, so what happens when you have a nice simple one and we say it's greater than 0? Well, do you need to graph it? Nope, you don't. You don't really need to graph it. You could, and it would be a good way to do it, see where the function is bigger than 0. Okay? But if you want to figure out where this thing is bigger than 0, you could do a sign chart. We did this last week. And that's where we try to figure out what are the important spots, and we put them on here. What do you think the important spots of our rational function are? They're what make the top 0 and what makes the bottom 0. Is there anything that makes the top 0? No. Is there anything that makes the bottom 0? Yeah, negative 3. So negative 3 is obviously an important point. Everybody start with this, and then try to figure out how to answer the question by just figuring out where the answer is on the number line. Is it like here? Try to figure out what makes this function bigger than 0. I'm going to pause while you and your partner work that through. All right. Did you say negative 3 itself? Would negative 3 itself work? Would negative 3 itself make this thing bigger than 0? No, it does not. In fact, it doesn't work on a big scale. It crashes the function, so it's a really bad thing. Okay, you could put a U there for undefined. That is not part of the grade. It's just like a hint for yourself that it's undefined at that spot, and therefore it can't possibly work in any function. Okay, next we should test something that's bigger than negative 3, like, I don't know, negative 2, or even something simpler like 0 is bigger than negative 3, right? We stick a 0 in and we see if it worked. If I put a 0 right here, I get 1/3. 1/3 bigger than 0? It is, so it seems to work here. And then how about something smaller than negative 3, like negative 4? If I put in negative 4, I get 1 over negative 1, which makes negative 1. Is negative 1 greater than 0? No, it's not, and therefore it doesn't work down here, and therefore you got your answer. It's between negative 3 and infinity. As you can see, way easier than the kind I was doing a second ago. I saw that cell phone come out. It needs to go away now. All right, next. I'd like you to take this one and find out when it's less than 0. I'm going to pause for a minute. Hint, you want to hit all the spots that make it 0 or that make it crash. Put them on the number line and then test around in those intervals. If you wanted to, you could graph the whole thing and see where it's under 0 or under the the x-axis. I'm going to pause while you try that. Okay, need to speed this process up a little bit. Here's negative 4. Here is negative 2. And here is 3. Why did I choose those numbers? Because they're the things that would either make the bottom crash like this, which makes it undefined. I'm putting a little U here to make sure I don't fill everything in that circle, because it can never work. And how about negative 2? That also is an undefined spot. And the negative 4, if you wanted to label this with a Z, that's a 0. And then think about it. If it's a 0, it will make the function equal 0. Is 0 less than 0? No, it's not, so it doesn't work there. If this had had an or equal to, then your Z or 0 would have worked. Okay, but this wasn't or equal to, so it doesn't work. Now I got to test my little intervals. Save me some time. Anybody find an interval where it worked? Like out here, does it work or not work? All right, then apparently you haven't tested the intervals. Take the time to test in here, and here, and here, and here. There's 4 places. My experience tells me that all of you are going to get the zeros and the undefined spots right. Everybody gets these points right, but people shade in crazy places. They don't know how to test intervals, so I need you to practice this. Pick a number that's in the interval, stick it in the function, see if it works. I'm going to pause for a second. Let me give this a try. So just to clarify, let's say you were going to stick in 4 to test this interval, because that's where 4 would be. You would then stick a 4 in the function and see if it actually comes out less than 0. Pausing again. Okay, so where does it work? Where does it not work? When I stuck a 4 in, it came out, I don't even care what that number is, just if that it's positive. I know it's 8, but do you get that it'll get complicated when I throw in decimals and stuff? If I just put in that this is positive, and this is positive, everything's positive, which means it must be less than 0? No, it must be a positive number, and therefore not less than 0. Okay, so it doesn't work. How many of you knew that the end doesn't work? Okay, good. Any questions, comments, or all right? And let's test something in between negative 2 and 3. How about like 0? 0's in there. If I put in 0, that's a nice one to test. It just makes it 4 over negative 3 and positive 2, but I'm going to say it makes it positive over negative. See, this part comes out positive. This part comes out negative. 0 minus 3 is negative. And this part comes out positive. Do you get there's only one negative in the whole thing? Which means it'll come out negative, right? Which means it'll be less than 0. It's a lot faster than actually getting the numerical answer every time. But it'll come out to a negative number, and therefore it's less than 0, and therefore it works. Who had shaded in this little zone? You were correct. Okay, and then how about this spot? Negative 3 is the only logical thing to check. Well, at least the logical integer to check. So if I put in a negative 3, I will have a positive and a negative and a negative. What is a positive and 2 negatives all boil down to? Positive. Is a positive less than 0? No, it's not, so it doesn't work. And I bet you this area works, but I don't know until I test it. Okay, I'm going to test negative 5 and see if it works. That'll make a negative. Negative 5 going in here makes it negative and negative. It's 3 negatives. What does that make? Negative. Is a negative less than 0? Yes, it is, so it works, and there we go. Final answer, negative infinity to negative 4. Union with negative 2 to 3. Those are the sets of numbers that would make our rational function less than 0. All right, so that is testing intervals. Now, we got to get more back into the word problems. Pausing for a second. The word problem theme that I gave you was that the rate plus the rate will equal the rate. Okay, and so for example, if I am, I did that example of me picking weeds in my backyard. Okay, and let's say in 2 hours, I take data that I was able to pick 47 weeds. If I add my friend's rate, let's say he picks weeds this way, we have him go for 1.5 hours, and he picks 28 weeds. What can I figure out? I can figure out a rate, because a rate plus a rate will give you another rate. What will that rate be? It'll be some amount of weeds per hour that we can pick together. Now, would these be easy to add? No, because they don't have common denominators, but we could just add them all up and figure out that, oh, together then, right now we have hours per weed. If I flip it over and make it weeds per hour, which might be a little like more normal way to think about it. I could figure out our combined rate. All right, so let's do another one. Yep, it is. Okay, so I'm going to give you another rate plus rate equals rate problem and see if you guys can figure it out. Okay, Joel is out catching fish. And let's assume for a moment that catching fish is something that you could be consistent at. It's not, because in the real world, you might catch them really well for like an hour and then they stop biting. Okay, but just imagine for a moment that Joe's rate could be consistent. Okay, and he's able to haul in 30 fish in 5 hours. Then his brother Bob goes out with him fishing, and together in 7 hours, I'm just going to write this kind of without giving you the exact way to write it. In 7 hours, they catch 70 fish. Try to set up and solve this problem. Joe's rate was 30 fish in 5 hours. Bob's rate, we don't know. But together, they were able to catch 70 fish in 7 hours. I'm going to pause for a minute and see if you could figure out how to set this up. Okay, there's more than one way you could have set this thing up. First off, did anybody notice that I used a number that would be fairly nice to like reduce? How many fish per hour was Joe catching? Okay, 6 fish for 1 hour plus Bob's rate per hour, we don't know. I'm going to put an X there because I don't know what it is, so X is a reasonable variable to use, right? And that's fish per hour. What's nice about making it per 1 hour is then the denominators are all ones, right? Makes the numbers a lot nicer. 6 plus blank equals, well, can we reduce 7 hours and 70 fish to what kind of a rate? 70 fish per 7 hours, so therefore 10 fish per 1 hour. Once you got it written this way, doesn't it look pretty easy? So what's X got to be? 6 fish per hour plus Must be 4 fish per hour. Would equal 10 fish per hour. So Bob catches fish at the rate of 4 fish per hour. All right. So we set that up so that we made the denominators all 1. It's not always going to work out that way, but that's a good way to do it if you can. If you can make the denominators 1, it makes it really easy. Okay. One other kind of word problem, the box problem. We've set it up multiple times now. By now, if you've been getting it wrong every time, you got to get this straight. If that's an X, an X, and an X, and an X, if I cut out on the dotted lines and make this into a box that will fold up, would you tell me the volume of this box again if the original dimensions was 36 by 24? Tell me what the volume of the box is in terms of X. Let's pause for a second. Let me give that a try. All right, I've got a system for word problems that's actually really good. Okay, word problems are tough, but if you use this system, it helps a lot. First step is to draw and label your diagram. Well, so far, I have kind of done the drawing and the labeling of the diagram, but I really haven't done a great job because once it's all folded up, its dimensions aren't 36 and 24 anymore, right? Once it's all folded up, it's 36. I'll do these in a different color maybe. It's 36 minus what? 2x on this side. That's how long this side is. And this side is 24 minus 2x. That way. And the third dimension, you have to be able to visualize this. After I fold it and cut out those corners, the third dimension is the height. And it's what? Just x. Good. Next, I have drawn and labeled a picture. The next thing is I bring in the full-sized formula, the original formula that involves volume. What is volume for a box? Length times width times height. And yes, you could go area of the base times the height. That also works. All right. Length times width times height. Notice I start with the original formula, all of it. If you just try to do parts in your head, you're not going to know where to stick stuff. All right, next they're going to say something like this. The volume of my box needs to be at least 1,000 cubic, what are these in? Inches. Well, is it possible that we don't have enough cardboard? It is possible. Okay, well, how do you prove to your boss, we don't have enough cardboard, this is not going to possibly work? Well, you'd set up an equation. And this time I want length, except I'm not going to say length. I'm going to put in, okay, so steps in the process. First, I drew and labeled a picture. Second, I wrote the original form of the formula out. Third, I take the stuff from the picture and I put it into the formula. Length isn't length anymore. Length is the longer of the two, which is 36 minus 2x. The width is 24 minus 2x. And the height is x. And all of that needs to be equal to the volume. No. What did I say? I wanted it to be at least what? 1,000. How do I make this at least 1,000? Greater than or equal to 1,000. My volume has to be greater than or equal to 1,000. All right, now, how do you actually solve a hard problem like that? Then you would graph both sides and see where they cross. That is a polynomial. If you multiplied it all the way out, it's going to be this curvy polynomial. It might look something like that. And then I have a line at 1,000. And that might look something like that. And then I just have to figure out, where is my volume above 1,000? Oh, it's in this zone where it's bigger than that. And that brings up this last point, which is the domain. Do you get I can't just cut any number I want out of the side? Because the smaller side here is 24. Do you get that my x can't be bigger than 12? Because if I'm going to cut x out of this side and this side, that's a total of 24, right? And I don't have a box anymore. Do you get that my x has to be between 0? If I cut out 0, I won't have a box. And 12, which is the biggest I can cut out. That's the domain of this thing, is that x has to be between 0 and 12, like that. Can't be 12 either. If you cut out 12 on each side, I won't have a box anymore. If I go 12 this way and 12 that way. Okay, so it's got to be between 0 and 12. Now do you get, then this answer over here is probably an extraneous answer. Won't work because it's too big. And then you're looking for the part of your graph that's in your domain. All right, so the only thing that's different than the last time you took a test, you took a test, you had the same exact question on it, is now we're going to set the thing greater than or equal to 1,000. And if we're going to take the next step and actually get the answer, you have to actually graph both sides and see where they cross. You cannot solve this in your head. There's no way. Algebraically, oh my gosh, you'd have to graph it. And interpret your graph and say, okay, I guess only answers between x is 0 and 12 need apply, so only answers in this zone. So, oh, I guess my answer's right there. That's where it's above 1,000. All right, I know that was really intense, but it is mostly review. The only thing that's new, we're going to be setting it as an inequality, and then this domain, which a lot of you got wrong before, you have to now really understand, and then you have to interpret that in the context of your graph. That, oh, it's only between 0 and 12 that this can possibly even work. Okay. There. Now I've taught you everything that you need to know for the test. But, obviously, you need time to practice. So we'll have some homework for tonight to practice this, and have some homework for tomorrow, which, again, practices this. And then the good news is the test on Wednesday, because we know it's going to be a little tough and rushed and not easy to do, you'll have a partner for it. But it'll be a partner chosen by us and ability grouped instead of just who happens to be sitting next to you. The people that have the straight A's in here are going to be sitting right next to a person that has a straight A in here. That has been research proven to get the best results. Not only, of course, it keeps the straight A kid from just doing the whole test for the kid who normally gets C's and doesn't know what's going on. The groups get along better because, somebody who's totally way ahead is a little annoyed that they have to drag along the other person. If you both have about the same grades as each other, you're also able to understand each other a little bit better. So anyway, it's been proven on multiple instances, and almost all math teachers do this when you group nowadays. So I'm going to simply do a sweep of the grade book, and it'll be maybe interesting for you to know who you're with. You won't know necessarily exactly where you are, because I'm not going to publish and say, you are the number 1 in the class, and you are the number 31 in the class. I'm not going to say that, okay? I'm not going to tell you where you are, but I'm going to just tell you somebody who's got basically the same grade as you, as your partner. Okay? All right, that's for Wednesday's test. Now, usually what happens about now is after class, somebody's going to be like, I've got a really low grade right now, but I'm actually much smarter than my grade is showing. Well, you want to turn stuff in between now and Wednesday, and yeah, I can, make your grade more representative of where you really are at. It's always pretty funny that people are like, but I don't want to be grouped with somebody who's got a bad grade just because I got a bad grade. They want somebody who's got a better grade than them. But if your grade doesn't represent where you're at right now, talk to me about it. Like, for instance, here's a good, fair example. Let's say a kid has a 0 in for a test right now. Do you get I probably shouldn't include that as a 0? Okay, so that would be an okay thing to remind me about, is if you have a test missing, I can go back and excuse the test so that you can be actually, like, that's more what your grade's like with that test excused. That would be a reasonable request. Okay, so let's actually look at the homework. I'm going to pause for a second. We find it. So this one, it doesn't look like it's part of the homework, but it's the first question I want you to do. We're going to definitely be doing a hodgepodge today of a problem here and a problem there kind of thing. Okay, I'm going to keep it reasonably sized, but this is the type of question you have to be able to handle. Rate plus a rate equals a rate. Okay? All right. Next, I'm not going to do that river question. Oh, this garden weeding question. Okay? I'd like you to try the garden weeding question. That's, again, a rate plus a rate equals a rate. And I'm going to even tell you, by removing this, that it's Taylor's rate plus Carl's rate would be the rate for both. Rate plus the rate equals a rate. All right. Moving on. There's a box question. I think it's a little maybe beyond you because of this stuff. We're not going to be having that exact kind of stuff for you to know, but basically a reminder that the box questions are important. You don't have to do that box question. If you want to look at it, you can. Wouldn't hurt. Next up, to solve these rationals, they're the kind where we've done this since the beginning of the year. How do you clear a fraction? You multiply by the denominator. Okay, I'd like you to do, let's just do this one and this one. You multiply both sides by the denominator. The top one, you're going to multiply both sides by 5x plus 4. And then you solve it and see what happens. On this one, when we multiply both sides by x plus 1, this one will cancel. This one becomes a quadratic. Then you got to move it and set it equal to 0. And then if you can factor it, you should. And what if you can't factor it? How are you supposed to solve a quadratic if it don't factor? Quadratic formula. Yep. All right, those two are assigned. Then we need to do a couple of these. That's the kind we practiced earlier. I'd like to do this one and this one. And hint, if you can factor it, you should. And you can on one of these. Nope, skip the top one. All right. And these, to be honest, for some reason, the way these are set up, these even confuse me, so I'm going to have you skip those. Again, if you want to go deeper and you feel like word problems are your nemesis, there is the answer key, and you could check out number 21. Number 21 in particular is better than the 22. You can look at the answer key if you want to. Again, these are ones you can explore if you know you're going to have trouble on Wednesday, but I'm not assigning them tonight. All right. And last one I am assigning is the llama question. Because it's a classic. On his own, he can clean the pen in an hour. How long, blah, 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 blah. So it's a rate plus a rate equals a rate, that kind of question. There was one more important question than anything else today. It's probably learning the rate plus the rate equals the rate kind. So this llama question would be a critical thing to learn today. All right. And that brings us up to the end of the hour. And I wish I could just make your life easy and only have one problem tonight, but we got a lot to get done by Wednesday. So get those puppies done tonight, and that's all I got for you for today.